So there are some coatings, like they have, like as I said, the primary paint system for atmospheric corrosion for big tanks. For example, all these tank farms that they are painted, this coating they should have the primer, and then the primer is basically the system for control in atmospheric corrosion. But then we have the cathodic protection. There are some other coatings, like when we walk and we see the fences that are for metallic fences with basically steel or silver color, and those are like basically diamonds or squares, like full of squares, and this is some sort of cathodic protection when they apply to the metal and as pigmented. So this is basically the galvanized material. What is the galvanized doing is basically they are the powder of metal, the pigment, for example, zinc. So the zinc we saw in the galvanic exercise, in the galvanic corrosion or the cathodic protection, that zinc, it's a material that tends to protect the steel. So they usually paint and they add zinc powder, that when it's in the paint, they start to act and start to protect the carbon steel. It is very well utilized for all this atmospheric corrosion when the stuff is exposed. What's going on when it's exposed? Condensation happens, so it's the moisture is deposited on top of the structure, and then the zinc start to be corroding and protecting the zinc start to be corroding and protect the iron or the steel. As I said, there is not such a perfect coating, so the design allows some percentage of permeability. When the coating fails and we have holes there or anomalies, there's called a holiday in the coating. So there's a holiday in the coating, means the coating has a hole, and then the pitting corrosion or crevice corrosion could initiate. So I will talk about pitting and crevice corrosion in other videos, just to illustrate the effect of damaged coating or damaged scales on the corrosion mechanisms. For cathodic protection, coatings should be designed in conjunction with CP. As we saw with the cathodic protection example, there is the first formula. It includes the coating factor. We need to consider the coating factor at the moment of designing the CP system. There's another type of coating, which is the internal. So it's the liner. You see here is the steel pipeline, and they are putting a liner inside. So the liner, as I said, it's permeable. Not everything is such thing that is perfect, that doesn't allow the gases to move or the gases to penetrate through. So they need to have, and they install, if you can see here, this is venting. So those are stainless steel venting systems, because the gas permeates from the inside, through the liner, to the outside, to the annulus. And this pressure could be so high that can collapse the plastic or the non-metallic material there. They can collapse it, and then we can break it and have a breach of the liner. So those are high-density polyethylene, which are non-pressure containers. Some of them, where the HDPE is a non-pressure container, and they are used, basically they use the steel as the pressure container. There are some other non-metallic materials that could be used to avoid the steel, but this is for corrosion protection, just for corrosion protection. These liners are not only used to protect pipelines, it could be also used to protect tanks. Inside the vessels, they sometimes they add a jacket of HDPE liners.